8b says, talking about scientific notation here. So again, I'm going to be doing the evens, but I'm going to try to help you out getting better at this. So look where the decimal place is. This is decimal notation right now. Look at this decimal place and try to convert it. We want to bring it all the way over 1, 2, 3, 4, only 5 spots. Because if I bring it over 5 spots, it now says 4.038. Well, to get it to scientific notation, we multiply by 10 raised to the however many places we moved. Well, I moved 1, 2, 3, 4, 5. So at this point, you're thinking it's either 5 or it's -5. Rather than memorizing, I want you to really think about it. If I put 5 here, pretend this is your problem now, and I'm telling you to go into decimal notation. Your first maneuver would be to move this to the right 5 places. That's way bigger than number 12 here. So that's got to be wrong. So what we do is we say, oh, that doesn't make sense, and I put a -5. So this is the correct scientific notation. And basically what I just said was if you have a positive power, you move it to the right 6 spots. So number 14, we go 1, 2, 3 spots. If I move it 3 spots, I'm at 9056. But I need to go 1, 2, 3 places more, so I need to tack on 3 zeros to this problem. Starting from the right, going to the left, every 3 I put a comma, and in decimal notation, that would be 9,056,000. Okay? Right there is the exact same number of the number of times you have smiled this year in math class. Very coincidental there. All right, so moving along here. We talked about things that are not polynomials. Very specifically, we don't have x to negative exponents, we don't have x to fractional exponents, and we don't have x's in the denominator. Okay? So looking through here, this says, are the following expressions polynomials, yes or no? I can do all of these really quick, so we'll just do all of them here. See how this one? Boom. Fractional exponent, not. That's why not. I'm just going to speak it out to you. It's not because of the fractional exponent. Looking here, ooh, is that one going to be okay? This is a little bit advanced here. I'm trying to stretch your thinking a little bit here. But the radical, if you think about it, have we had any of those? No, but also a little bit of information for you. A radical is exactly the same as raising that to a 1/2 exponent. So if you take the square root of 9, we know that's 3. So try it on your calculator. If you do 9 and you raise it to the 1/2 power, you actually also get 3. So this is a long explanation, not trying to confuse you. It has a fractional exponent, so it can't be a polynomial. And then if you look at the other two, there's no problem at all on those. Those are both polynomials. They don't have any of these issues. Okay? Now looking at number 20. Again, like I said on the quiz, the addition literally means you're just combining like terms. There's really a positive 1 here, but when we distribute it, nothing changes. So I'm taking the 8x squared, and I'm going, okay, well that doesn't have any like terms. -7x and +5x has a -2x's. +2 and a -5, that does combine to -3. So real simple. Just combining like terms on that problem. Okay, moving on to the last page, I'll do the evens here. We do have to distribute on this problem twice before we combine like terms. So distributing the 4 through, we're going to get 8x minus 20. And then we need to be very careful. Please be very, very careful here. Highlight this. When you distribute, you have to distribute the entire -3x. So being careful here, we distribute that -3x times 3x. That's a -9, but it's x squared. And then -3x times 2 is a -6x. So if you tried this first, and now you're watching the video, if you forgot a negative here, that's where you made a mistake, not distributing that negative. Okay? Now you can write this in different orders, but 8x and -6x together makes 2x. We have -20, and we have -9x squared. We've been talking about writing these in descending order a lot, meaning highest power down. That would look like this. Keep the sign in front the same. There's really a positive 2x, and there's a -20. Both of these are completely acceptable answers. Okay, number 24, here's our chance. to show our foiling skills. So 8x times 2x, sorry, I'll write this out. FOIL time, product, multiplication of two binomials. 8x times 2x, 16x squared. 8x times 3y, positive 24xy. Where am I at? Inside, negative 6xy. And then last would be negative 9y squared. And when we combine like terms, we're going to have 16x squared, positive 24xy, negative 6xy, combines to 18xy, and then we have minus 9y squared. And that is the most simplified answer. We are done with that second degree trinomial. All right, moving along. We have number 26, 28, and 30 to do here. This here, remember, do not bring this through. Do not bring these through on these two. Realize that a number squared is equal to that number times itself. So this squared is the same thing as x minus 5y times x minus 5y. Now, if you're following, you realize two binomials multiplied is going to give me foiling. So now we FOIL again. So what I would say on this one is you rewrite the problem, then FOIL. X times x, we got an x squared. Outside, negative 5xy. Coincidentally, on the inside, we get negative 5xy. And then on the outside, a negative times a negative is a positive 25y squared. All right, so looking here, we can combine the inner terms. X squared minus 10xy plus 25y squared. And that is the final answer for that binomial squared, which we rewrote and then did FOIL. All right, looking at 28. Hopefully the distributive alarm is going crazy in your head. Distribute, distribute, distribute. Follow your rules. When you distribute, you're multiplying. 5 times 4, 20. A times a squared, a to the third power. When we're multiplying the like bases, we add the exponents. And then we have to tack a b on there. Positive 5 times positive 3, positive 15. A times a squared. B times b squared. Now we bring through positive 5 times negative 7, negative 35. A times, oh, no other a there, so I just leave the a. B times b squared is going to give me b cubed. And that is as far as we can go, because if you look at it, be very careful. This one here and this one here are not like terms. They're not same variables, same exponents, so we can't go any further. All right, now this last one here, since it's an even, it's kind of just a little extra challenge for you. But look at 29 over here. If you have a binomial times a trinomial, you distribute 3 times with the first one and 3 times with the second one. So that's still happening here. You're multiplying a trinomial times a binomial. So you can rewrite it like this first one if you want to, or you can just be like, all right, I'm going to take the 4x through 3 times. And that's what I'm going to show you here. So 4x times 4x squared is 16x squared. 4x times positive 2x is plus, oh, I'm sorry. Made a mistake. Not the last I'll make. 4x times 4x squared is 16x, but that should be to the third power. And then 4x times 2x would be plus 8x squared. And then 4x times negative 7 would be negative 28x. And then I'm going to grab another color here. We'll go blue. Be careful now. When you do the next distribution, it's the negative 3, the entire negative 3, not just 3. So negative 3 times 4x squared is negative 12x squared. I might run out of room here. And then you take negative 3 times 2x, negative 6x. And negative 3 times negative 7, we'll try to squeeze it in here, as a positive 21. So now what we look for are like terms. I do not have any other 16x, I do not have any other x cubed terms. So I'm just leaving it as 16x cubed. I do have 8x squared and negative 12x squared. Combine those together, it's actually a negative 4x squared. We got negative 28x and negative 6x for negative 34x's. And then the 21 is all by itself over here. So we are done with that 4-term polynomial of degree 3 in descending order. I really hope this helped. I hope you guys are using these YouTube videos. Tell your friends, tell your families, and learn some math. Good luck tomorrow on your test, and I will see you in a bit.